Okay, 7.3.4 maximum and minimum value of trigonometric expression. Okay, so in this part, what we're going to do is we're going to find the maximum and minimum value for any trigonometric expression. Alright, so dalam bahagian ni kita nak cari nilai minimum dan nilai maksimum bagi sesuatu ungkapan trigonometrik. Alright, so we're going to take a look at example 39. So we directly discuss the example. So from there we can understand what we want to do here. Right, so example 39. Okay, find the maximum and minimum value of the trigonometric expression below. Alright, so we have 6 question here. Okay, so first we need to find the maximum and minimum value for the expression to cos theta. Alright, so to find maximum and minimum, what we do, we just substitute cos theta here with 1 and -1. Okay, but why we want to substitute cos theta equals to 1 and -1? Alright, this is because if we look at the graph for sine and cos, okay, so let's say I sketch the graph for function cos. So y is equals to cos x. Alright, so this is graph for cosecant x. So we can see that the graph is oscillating and the maximum or the greatest value that the graph will hit is 1. Okay, up here is 1, and the minimum value, okay, that this graph hit is -1. So regardless of any of what is the angle here, okay, whether this is x, okay, jadi angle ni tak kisah pun apa sahaja. Okay, kalau contohnya kita ambil 2x, okay, dia masih maksimum dan minimum dia masih lagi between 1 and -1. Okay, 2x plus 3, still the same. Okay, maximum is 1, minimum is -1. Okay, so that's mean cos, okay, angle anything, maximum always 1 and minimum always -1. So also the same with sine. Okay, sine pun sama. Okay, maximum is always 1, minimum always -1. So and the angle also stay the same. Okay, regardless what is the angle, let's say 2x, also still the maximum and minimum is 1 and -1. Okay, so divided by 3, 5, still maximum 1, minimum -1. Okay, so from this information, so what we're going to do is we just substitute, okay, cos, okay, any angle with 1 and -1. Alright, so what we're going to do is we're going to substitute, okay, we're going to substitute cos theta by 1 and cos theta equals to -1. So first, if we substitute cos theta equals to 1, so we will get 2. And if we substitute cos theta equals to -1, we get -2. So now we have two value here, 2 and -2. And the largest value is maximum. So 2 is the largest value. So this is maximum value. And -2 is the minimum value. Alright, so that's how we find maximum and minimum value. Okay, very easy, senang je. Okay, ganti je 1 dan -1. Alright, so B. Alright, so B is minus 5 sine theta. Alright, so to find maximum and minimum, we just substitute, okay, sine theta, okay, just sine theta, okay, depan ni tak payah ambil, start pada sine, okay, theta belakang tu tak kisah apa pun, okay, sine theta by 1 and negative 1. So sine theta equals to 1 and sine theta equals to negative 1. So we're going to get 5, negative 5 times 1, which is negative 5, and negative 5 times negative 1, which is 5. So 5 is the greatest value, so this is maximum, and this is minimum value. Alright, C is 4 cos 2 theta plus 3. Alright, so yang ini, for this one we substitute. Okay, for cos 2 theta. Okay, angle ni tak kisah 2 theta, okay, 3 theta, tak kisah, asalkan depan dia cos ataupun sin. Alright, so we substitute cos 2 theta by 1 and another one cos 2 theta equals to negative 1. So we get first, okay, 4 times 1 plus 3, which is 7, and 4 times negative 1 plus 3 equals to, this is minus 4 plus 3, so this is negative 1. Okay, this is 7. Alright, so 7 is the maximum value and negative 1 is the minimum value. Alright, D is 5 sine theta plus 30 degree. Alright, so now we're going to substitute for sine theta plus 30 degree by 1 and negative 1. Okay, so sini ni kena hati-hati lah. Okay, sini cos 2 theta plus 3. Okay, 3 ni dia tak termasuk dalam angle ni. Okay, so dia asing lah 3. Tapi yang ini cos sin theta plus 30. So plus 30 ni is inside the angle. So we take the whole sin theta plus 30. Okay, so sin theta plus 30 we're going to substitute by 1 and negative 1. So we substitute sin theta plus 30 degree by 1 and sin theta plus 30 degree by negative 1. So we have 5 times 1, which is equals to 5. 5 times negative 1, which is negative 5. Okay, so 5 is the maximum value and negative 5 is minimum value. Okay, so this is D. So E is 2 negative 2 cos theta minus 60 degree. Okay, so this is the same with the previous question, where we're going to substitute cos theta minus 60 degree. So ambil sekali lah dengan so nak ganti tu just ganti, okay, sin belakang ni tak kisah apa pun. Okay, bukan tak kisah apa pun, maksudnya angle dalam tu can be anything lah. Okay, angle can be anything. Okay, so we just substitute 1 and negative 1. So substitute, okay, cos theta minus 60 by 1 and negative 1. Okay, so we get negative 2 times 1, which is negative 2. Negative 2 times negative 1, which is 2. So this is minimum value and this is maximum value. Alright, so that's how we find the maximum and minimum value. Just substitute 1 and negative 1. Alright, so let's take a look at example 40. Okay, find the maximum and minimum value for the expression 3 sin x minus 4 cos x and find the value of x where the expression has the extreme value. Alright, so for example 40, okay, first we need to find the maximum and minimum value for 3 sin x minus 4 cos x. Right, so for this question we cannot substitute sin and cos 1 and negative 1. Why? Because here we have both. Okay, ini dia bercampur, dia ada sin dan dia ada cos serentak. Okay, beza dengan contoh sebelum ni, dia satu je. Okay, only one. Okay, only cos, only sin, only cos 2 theta, only cos theta plus 30 degree, only cos theta minus 60. Okay, only one. Okay, but in example 40, we have two. Okay, which is sin and cos. We cannot substitute sin equals to 1 and then cos equals to 1 because sin x cannot be the same with the cos x. Okay, when sin x equals to 1, cos x cannot be 1. Okay, so we need to change this to the form where we can when this is single. Alright, so actually yang ini adalah linear. This is linear form. Okay, so in linear, okay, we have a method to change from this linear form to a single, where we change it to the form of either r sine theta plus or minus alpha, or in a form of r r cos theta plus or minus alpha. But for this question, dia tak bagi dia tak bagi nak ganti guna apa. Okay, so yang ini saya bagi tahu lah, kita akan guna. So for 3 sin x minus 4 cos x, okay, yang paling sesuai adalah kita akan guna r sin x minus alpha. Okay, so macam mana kita tahu nak guna yang ni? Okay, cara dia adalah, okay, sebenarnya sini dia ada 4 kita sama ada, so I will write all of that, mana dia plus ataupun r sin theta minus alpha, r cos theta plus alpha, r cos theta minus alpha. So basically question will give, okay, what expression that we going to use, but sometimes, okay, we need to choose by ourselves. Alright, so to choose, okay, here we can expand first. If we expand, this is r sin theta, r sin theta cos alpha plus r cos theta sin alpha. Okay, this is r sin theta cos alpha minus r cos theta sin alpha. This is r cos theta cos alpha minus r sin theta sin alpha. Okay, and this one is r cos theta cos alpha plus r sin theta sin alpha. Okay, so to choose the suitable form is like this. Right, so we take a look at our expression here. We have 3 sin x minus 4 cos x. Alright, so the first term must be sin and the second term must be cos. Okay, so in this term, okay, yang mana yang ada sin lepas tu baru cos adalah bentuk sin theta plus alpha. Okay, yang sesuainya adalah r sin, bukan r cos, sebab r cos yang pertama ni cos, lepas tu baru sin. Okay, kemudian yang kedua pula kita kena tengok sin kat sini. Kalau sini minus, so yang sesuainya adalah yang minus jugalah. Okay, so kalau sini minus, so kita pilih yang minus. So yang paling sesuai adalah r sin theta minus alpha. Okay, so that's how we choose, okay, the suitable substitution. Okay, and then we can solve this. So r, okay, sin x cos alpha minus r cos x sin alpha is equals to 3 sin x minus 4 cos x. So we can compare. So if we compare, we get r cos alpha equals to 3 and r sine alpha equals to 4. So this is first equation and this is second equation, and then we can find r. So r is square root 3 squared plus 4 squared. Alright, so this is 5. And alpha, so we take r sine alpha equals to 4 divided by r cos alpha equals to 3. So this will become tangent alpha equals to 4 over 3. So alpha is arctangent 4 over 3. So arctangent 4 over 3 is 53.13. Alright, so that's mean, okay, 3 sine x minus 4 cos x is equals to 5 sine x minus 53.13 degree. Alright, so to find the maximum and minimum value, we just substitute for sine x minus 53.13 by 1 and negative 1. So when sine is equals to 1, so we get 5 times 1, which is 5, and then 5 times negative 1, which is negative 5. So the maximum value is 5 and the minimum value is negative 5. Okay, so that's how we find the solution for this question. Alright, so we get the maximum and minimum value. Alright, so next part is find the value of x where, okay, for which the expression has the extreme value. Alright, so soalan ni maksudnya, okay, dia adalah this equation when, that's mean maksudnya kita kena solve untuk soalan macam ni lah. Sin 3 sin x minus 4 cos x is equals to the maximum value. Okay, the extreme value, that's mean the maximum value lah, which is equals to 5. Okay, so we need to solve this. Okay, so to solve this, first kita boleh tukar dulu 3 sin x minus 4 cos x as 5 sin x minus 53.13 equals to 5. So divide both sides by 5, we get 1. So sin x minus 53.13 is equals to 1. So this is in a single form, so we find alpha. So alpha is arcsine 1. So alpha is equals to 90 degree. Alright, and then we determine which quadrant. So alpha, so x minus 53.13 should be in first and second quadrant. Okay, because this is sign positive, so sign positive in first and second quadrant. So in first quadrant is 90 degree and the second quadrant also 90 degrees. So that's mean it is the same answer for first and second, because 90 degree is in between first and second quadrant. This is 90 degree. Okay, alright, so we just have one answer here. So to get x, so x is 90 degree plus 53.13. So the answer is 143.13 degree. Alright, so that's how we solve this question.